Module 24, Nonlinear Regression, Multiple Regression and Logistic Regression. Section 3, Logistic Regression. So logistic regression is a subtype of multiple regression when outcome or response or dependent variable is binary. So multiple logistic regression is the better way to say what this logistic regression is. Always multiple, and it is again it is basically linear regression type only. It is again multiple regression is also a kind of a linear regression, but it's basically multiple. The more than one variable is used at the same time. So in this case it is binary. The outcome variable is binary, that is dichotomous, and discrete. There are only two possible outcomes, 0 or 1. So we learned how to deal with this with the contingency table, and most of these biological as well as epidemiological data tend to be like this. And we also discussed about the binomial distribution as well as Poisson for the discrete, but binomial distribution is apt for this kind of data, and chi-square test can also be used for this. But Fisher's exact test is more appropriate for binary data. So this is also a test for binary data. For the regression test appropriate for binary data is logistic regression. So example is death during the surgery, yes or no, or graduation, yes or no, or recurrence of illness, yes or no. So it's always 0 or 1, yes or no. So it's always a binary outcome. So in that case it is logistic regression is the best choice. So treatment variables need not to be in the binary. So it is only the outcome variable need to be the binary, but treatment variable could be a continuous variable as well. One example is that does obesity, that is a dependent variable, affected by 8 other independent variables. So is it actually affecting or not, to see that is how many are confounding factors to see. So to see that, what all you have to do is that you have to see that different things, you have to calculate odds ratio for this. So you have to adjust with multiplicity adjusted OR you have to find. So that is why you have to take a logistic regression model to do this work. So here logistic regression computes odds ratio or OR explained in module number 20. For each of these 8 independent variables, so OR, that is odds ratio for becoming obese for a particular subject. So for example urban versus rural. So what is actually the odds for urban to become obese? So everything, the odds for becoming obese is what is being calculated here in this model. So the model is exactly like our multiple regression model. So here it is little bit differences only here. Let us say y is equal to beta 0, that is a baseline without any effect in, or you can call it as a null hypothesis, plus beta 1 multiplied by x1 plus beta 2 multiplied by x2 plus, and goes on till the last parameter that you are going to, or variable that you are going to measure. All this beta, these are nothing but parameters. That is what is being estimated in this regression method. So y is equal to, is basically natural logs of odds for a particular subject. For example urban. So urban woman, what is that, the natural logs of the odd you can calculate by plugging in all the variables into this equation. So like that you can calculate the odds for every other 7 variables as well. So that is what this logistic regression calculates. So beta 0 is natural log of the baseline odds. If the independent variable x is 0, what is the odds for the obesity? That is what that thing calculates. So beta 1 is natural log of the odds ratio for the first independent variable, which is urban versus rural. So x2 is particular patient, the first independent variable is the urban versus rural. That is what that is what the x is about. So this one, the b1 is actually the natural logs of the odds ratio. So that way you can plug into this equation to find the y. So usually you don't have to do that manually. Everything, it's very easy to do that in a computer. So the computer will generate an odds ratio which has already been adjusted for all this logistic 8 different comparisons. So as you can see, the highest odds ratio is more than 2 odds ratio is for the urban. So what does that mean? So urban woman to become obese has odds of 2 something versus the rural woman having the odds of 1.0. So it's quite likely, the likelihood of becoming obese is higher for urban ladies than the rural ladies. So that is an interesting finding revealed by this Iranian study. So in summary, logistic regression is a subtype of the multiple regression when the outcome, that is response or dependent variable, is binary. Same set of assumptions used in multiple regression are used in logistic regression as well. Result is usually a summary table with odds ratio rather than a graph like best fit line. No, it's usually the logistic regression output is a table with odds ratio. Thanks for watching. I hope you like these modules of this week and have a nice time.